All right, so in this example, we're going to be looking at the analysis of variance of the ANOVA, and we're going to be doing this by hand. And so we're starting off here, we're comparing 4 different types of therapy, which we just have marked here and labeled A, B, C, and D. And we have 4 people in each group, and so we have 4 scores in each group. And we have these 4 different groups. And we can see here that we always want to make sure that we're paying attention to what information we're given at the beginning of the problem. And in addition to our raw scores here, we also have the means and the estimated population variance for each group. And so that's going to give us a head start, and we'll be able to move ahead a little bit faster because we won't have to calculate those means and estimated population variances for each group. And so starting off our research with our research hypothesis, our first step of our hypothesis testing procedure. Want to get those research hypothesis and null hypothesis for our particular analysis. And in this case, we can say that people who participate in the 4 different groups will perform differently from the participants in the other groups. And so participants in one group will perform differently than the participants in another group. Participants in different groups will score differently. And again, so we can imagine that this is perhaps an anxiety inventory that people are taking maybe a couple of weeks after they've started these different types of therapy. And for our null hypothesis, we can say that participants in all the groups will perform the same. I like to word the null hypothesis this way, which is a little different than how we've done it in our other examples for other tests, particularly because we have these additional groups when we're doing our ANOVA, and we can have a more specific hypothesis in our ANOVA for our research hypothesis. Here we can see that we're just predicting that they're going to score differently, but it is possible that we can have a particular or a very specific prediction, perhaps that group B is going to perform and score higher than group C. Things like that, or group D will have more of a reduction in symptoms than the other groups. And so we can be more specific here. And so I like to really word our null hypothesis saying that these, because it might not be adequate to just say that it will not be the case that our research hypothesis is true, because there could be other ways that our means will be different. And as we'll see later, as we're calculating the F score for our ANOVA, that F value, that the actual information that we get here really is just going to tell us whether our groups are the same or not how they're different. And so we'll look at that as we move forward here. And so step 2 here. In step 2, again, the ANOVA is going to be a little bit different. It flows a little bit more smoothly for us to just get our degrees of freedom in step 2, which is usually where we're getting our comparison distribution information. And we're actually going to do all of our other calculations in step 4, which is, again, deviates a little bit from what we normally do for instance, our t-tests. And so here what I'm going to be calculating is my DF between and DF within. So this is for our between groups and within groups degrees of freedom. And so for the between groups, I'm going to get n groups minus 1. And here I have 4 groups, so that's 4 minus 1. That's going to be 3. And our DF within is going to be our degrees of freedom for each individual group all added up. So DF1 plus DF2 and so on until the last degrees of freedom for the last group. And here we have 4 groups. So DF1 plus DF2 plus DF3 plus DF4. And a reminder that my degrees of freedom calculation is just going to be n minus 1. We have 4 people in each of our groups. That's 4 minus 1, and so that's going to be 3. And so here there's going to be 3 plus 3 plus 3 plus 3. And that's going to give me 12. And so when we get to step 3, we're going to move towards getting our cutoff score for our F distribution. And so we're going to use our degrees of freedom, which are 3 and 12 for our numerator and our denominator degrees of freedom. We're going to use a cutoff score of 0.05 here. And if we look that up on our F table, we're going to see that our cutoff score should be 3.49. And so now moving on to step 4 here. And again, step 4 here is going to be a little bit more lengthy. I'm going to move over here towards the left. And so the first thing that we're going to do when we're calculating our sample score, so here we're calculating our sample score, but we have some work to do before we get there. And so we have to really calculate 2 main things. We need our within groups estimate of the population variance, and we also need our between groups estimate of the population variance. And we need both of those before we calculate the F ratio. And for each of those 2 things that we need, there are actually a couple of steps that we need to do to get those. And so in order to get the within groups estimate of the population variance, we first need our estimated population variance for each of our groups. And in this case, we can see that this is one of the things that we do already have. We've been given this in the problem. And so this is going to save us really a bunch of time. If you're not sure how to estimate your population variance, then check one of the prior videos and you can go over that. In this case, we have that. And as you might be familiar, this is a multi-step process for each individual group. And we have 4 groups here. So this is going to, again, save us a bunch of time. But for step 4, I'm going to just kind of remind myself here that I would need this. And so I'm actually just going to put in for step A here what my estimated population variances are for each group. 1, 2, 3, and 4. I could say A, B, C, and D as well. I'm just going to write in what these are. And this way I know that I'm showing that I'm aware that I need to do this step. I'm aware that I already have this information. And this is the information. And this way I already know when I get to my next step, I know that this information is right here. My second step here, and this is to get this within groups estimate of the population variance. So this is the S squared. Then this is S squared 1. So then we're going to basically just essentially get an average of these estimated population variances. And so I'm going to add up as many as I have. I have 4 in this case. Squeeze that in here as I get to the edge of the sheet of paper. And this is going to be all over and groups. So the number of groups that I have. And so here, this is going to be 1 plus 3 plus 6.92 plus 14 and over 4 groups. And so if I add up 1 and 3, 6.92 and 14, I'm going to get 24.92. If I divide by 4, then I'm going to get 6.23. I'm going to put this number aside. This is my S squared within, and I'll be coming back to that in just a couple of steps. So the next thing that we need to do is to get the between groups estimate of the population variance. And so we're going to do, this is step C. And so in order to do this, this is S squared M equals, I'll make sure that it's very clear that I have an M here and not a mu. And it's going to be the sum of M minus GM. And so this is each individual sample mean minus the grand mean. I'm going to square that, get the sum, and divide by DF between. And so we're going to see that this looks really similar to our estimated population variance formula, or even just our variance formula. But we can see this is a little bit of a variation of that. And so this is the estimated variance of the distribution of means. And so to get our grand mean, we can go back up here, and we can go ahead and get the mean of all of our raw scores. And so we can get the average of these 16 raw scores, or I can just get the average of my averages, get the mean of my means. And so I can go ahead and get 12.5 plus 11.5 plus 10.25 plus 17, add that all up and divide by 4. And so when I do that, and so I'm going to calculate my grand mean here on the side. And so when I do that, I'm going to get 12.81. And then I can go ahead and start getting this variance. And so I'm going to take that grand mean and subtract it from each of these means. Square it, add them up, and divide by df between. And so I'm going to first start out just like I normally do when I'm doing a variance, just writing down each of these means. Usually we have our raw scores, but we have our means here. And we're plugging in that grand mean that we're subtracting by. And then we start subtracting. So 12.5 minus 12.81 is going to be negative 0.31. 11.5 minus 12.81 is going to be negative 1.31. 10.25 minus 12.81 is going to be negative 2.56. And 17 minus 12.81 is going to be 4.19. I'm going to go ahead and square all of these. And so again, we want to go up to at least 2 decimal places to make sure that we're being nice and precise. No more than 4 decimal places. And again, that's just to keep things easy and make sure that we're really rounding out the same amount for each of our numbers. And so 0.31 squared, and again, making sure that we're remembering that a negative squared is going to be a positive. 1.31, negative 1.31 squared, 1.7161, negative 2.56 squared, 6.556, and 4.19 squared, we're going to have 17.5561. And again, I always try to keep my decimal points lined up as much as possible, a little off here, but try to keep those lined up as much as I can. This way it's really clear what I'm adding up. And so as I add up these numbers, I'm going to get 25.9219. And I'm going to divide by our df between, which we had said is going to be 3. All right, so we divide that by 3. 25.9219 divided by 3. And we're going to get 8.64. This is our last step before we're going to calculate that F value. And so here what we're getting is, this is going to be our between groups estimate of the population variance. And so essentially this is the estimated variance of the population of individual scores that we're doing in this step. So this is going to be S squared between, and we're going to see this is going to be what we got in that last step, S squared M, multiplied by the number of scores in each group. And so this is 8.64, we have 4 scores in each group, so that's going to be 34.56. And so here, we're actually going to calculate our F value. And so this is our sample score at this point. And to do this, we're going to get the ratio of S squared between and S squared within. And so this is that between groups estimate of the population variance divided by that within groups estimate of the population variance. right? I can't remember which one goes on top. I try to remember that B comes before W, so the B comes on top, and the between goes on top, and the within goes on the bottom. And so we have our between groups estimate, we said is 34.56. Within groups estimate, we said is 6.23. And then our F value will be 5.55. One really important thing to note, and something that could be helpful, is if we don't remember what steps to do, but we know what our final step needs to be. So I know for my ANOVA, for instance, I need to get an F value. I can go ahead and find this formula to get this F value, and then I can work my way backwards and consider the fact that if I need S squared between and S squared within, then I know that I need to find formulas for F squared between and F squared within. And so then I can find this formula for F squared between, for instance, and I could see that I need N, I need my S squared M. Okay, well then if I don't have this already, if I'm not given this, then I need to calculate this. And then I can go and find this formula and so on. So I can keep working my way backwards if I know where I'm supposed to end up. But here we have each of our steps done at this point, and we have our sample score, we have our cutoff score. And so now step 5, we can go ahead and make our decision. And again, we could draw this out. I can draw the distribution. I know that the F value is going to be positively skewed. I could also just draw a number line here, and so I'll do that. And with our F value, we know this, there are no negative F values. I'll just draw this starting here. Our cutoff score, we said, is going to be 3.49. And our F value here is 5.55. This is our sample score. And so we can see our sample score is more extreme than our cutoff score. It's further in the tails than our cutoff score. And so we can reject our null hypothesis. Which means that our results are statistically significant. Because this is the ANOVA, we know that this is not really the end of this problem. We can reject our null hypothesis, but which of our groups are different? And so we know that our groups are different, but it's going to be relevant to know which group is different and in what way. And so we want to go ahead and do some of those follow-up tests. We're not going to be working on doing those follow-up tests by hand, and so we don't have to worry about that too much here, although it would be helpful for us to note whether we need to do a post hoc test or whether we have to do a planned comparison. And particularly that comes down to whether or not we have a specific hypothesis at our start. And here we just have this prediction about these different groups will score differently. We don't have a specific hypothesis, and so that would mean that we're going to want to go ahead and do post hoc tests. And so at the end here, again, we're not going to work on doing these by hand. Typically, we're going to be using statistical software for doing this kind of an analysis anyway, but we can say that we're going to proceed with post hoc tests. Again, those are to get those differences between our pairs to see which of our groups is different. We know one is because we've rejected this null hypothesis, but we need to find out which is different.